I am often asked why I once described the human landing on the moon as something that appeared impossible, and I want to be clear from the beginning that science does not measure history by disbelief, but by understanding. Because when I use the word impossible, I do not mean forbidden by nature, I mean resisted by it, challenged by it, pushed to the very edge of what the laws of physics would allow at that moment in human development. And when we examine the moon landing through the lens of science rather than nostalgia or emotion, we quickly discover how narrow the margin was between success and failure, how many variables had to align with extraordinary precision, how many equations had to be trusted long before they were fully tested, and how fragile the human body and human technology truly were when removed from the protective cocoon of Earth. Because to leave Earth is not merely to travel upward, is to escape a deep gravitational well, one that has shaped every biological system we possess, one that holds our atmosphere in place, shields us from radiation, and defines our sense of up and down. And to overcome this requires not only fuel and engines, but faith and mathematics, because rockets do not rise because of courage or ambition. They rise because equations say they must. And in the 1960s, many of those equations were still young, still being debated, still being tested in laboratories and wind tunnels rather than in the silent vacuum of space. And yet humans chose to trust them, knowing that a small error in velocity could miss the moon entirely, that a slight miscalculation in trajectory could trap astronauts in endless orbit, that a failure in heat shielding could erase them in seconds upon return. And this is why the moon landing appears impossible when viewed honestly. Because space is not forgiving, it does not care about flags or speeches or national pride. It only obeys physical law, and those laws are strict, because beyond Earth there is no air to breathe, no pressure to stabilize fluids, no magnetic field strong enough to deflect every particle of harmful radiation. And the human body did not evolve for such an environment. Our bones weaken, our muscles waste, our sense of balance collapses, our cells are exposed to cosmic forces that can damage the very instructions of life. And yet humans went anyway, enclosed in machines thinner than many modern vehicles, guided by computers weaker than devices people now carry casually, navigating by stars and radio signals across distances that dwarf all previous journeys. And when people ask why this was impossible, I answer that it was impossible in the same way flight once was, not because physics forbade it, but because it demanded perfection from imperfect beings. Because landing on the moon is not like landing on Earth. There is no atmosphere to slow you gently, no wind to correct your path, no runway to guide you, only gravity pulling you down at a different rate, only dust that behaves like powder and stone at the same time, only silence so complete that even sound does not exist. And to land safely requires reducing speed from thousands of kilometers per hour to zero with exact timing, because too fast means destruction, and too slow means falling back into orbit. And all of this had to be done while communicating across vast distances with delays that prevented instant correction, which meant astronauts were not simply passengers, but active participants in a complex experiment unfolding far from immediate help. And this is why I have always emphasized that the moon landing was not a triumph over nature, but a negotiation with it, a careful agreement between human curiosity and cosmic indifference, because physics allowed it, but only just. And when people doubt that humans could achieve such a feat, I remind them that doubt itself is a natural response to scale, because the moon is not just far away, it is far away in a way the human mind struggles to visualize. A distance so great that Earth shrinks to a fragile blue shape. A distance where survival depends entirely on understanding invisible forces. And yet this is precisely why the moon landing matters. Not as a symbol of dominance, but as evidence of comprehension. Because humans did not force their way to the moon, they calculated their way there. They learned how mass bends space, how momentum carries motion, how energy transforms under constraint. And they applied these lessons with humility and precision. And when I say it was impossible, I am inviting people to appreciate how close it was to the boundary between what we understood and what we did not, because history often simplifies achievement into inevitability. But nothing about the moon landing was inevitable. It was fragile at every stage. from launch vibrations that could tear systems apart, to navigation corrections measured in fractions of a degree, to life support systems that could not fail even briefly, to re-entry heat that turned the capsule into a controlled star. And all of this occurred while humans remained conscious, thinking, adapting, responding, and trusting that the universe would behave exactly as the equations predicted. And that is a remarkable act of confidence, not in machines, but in knowledge, because science is not a collection of facts. It is a method of asking questions and accepting answers even when they are uncomfortable, and the moon landing asked the universe a question of unprecedented scale, asking whether intelligence born on one small planet could understand enough about reality to step onto another world and return, and the universe answered yes, but only because humans listened carefully to its rules, and this is why claims of impossibility often arise. Because people imagine the moon landing as a simple act of travel rather than a delicate balance of forces. Because they underestimate how much planning and testing preceded it, how many failures taught lessons, how many unknowns were confronted with reasoning rather than fear, and how much patience was required to wait for the right moment, the right alignment, the right conditions. Because even the moon itself is not static. It moves, Earth moves, everything moves. And timing is as important as distance. And when we strip away myths and misunderstandings, what remains is something far more impressive than disbelief. Because the moon landing demonstrates that human limitation is not fixed. It shifts with understanding that what seems impossible in one generation becomes routine in the next. Not because nature changes, but because our models of it improve, and this lesson matters now more than ever. Because humanity faces challenges that also appear impossible. Challenges of climate, of energy, of survival beyond Earth. And the story of the moon landing reminds us that impossibility is often a signal, not of failure, but of incomplete knowledge, and that the correct response is not denial, but deeper inquiry, because when humans first looked at the moon, it was a mystery, a light in the night sky, unreachable and eternal. And when humans finally stood upon it, they did not conquer it. They left footprints that will last because there is no wind to erase them. And those footprints are not symbols of power, but of curiosity, of the willingness to test ideas against reality. And if there is one message I wish to leave, it is this: that the moon landing was not proof that humans can do anything, but proof that humans can do what they understand. And therefore, the greatest limit we face is not distance, not gravity, not technology, but ignorance. And as long as we continue to question, calculate, and learn, the boundary of the impossible will continue to move, just as it did when a species bound to Earth briefly touched another world and returned to tell the story. And yet, when we move beyond the achievement itself and examine what followed, we begin to understand that the moon landing was not an ending, but a question mark placed at the edge of human history, because once humans proved that they could leave Earth, even briefly, they unknowingly challenged the deepest assumptions about their place in the universe, assumptions that had guided philosophy, religion, and science for thousands of years, because for most of human existence, the sky was a boundary, a ceiling painted with lights whose movements were interpreted as messages or mysteries, and suddenly that ceiling became a destination. And this transformation did not occur because the universe invited us outward, but because curiosity compelled us forward. And curiosity is a force as real as gravity, because it pulls the human mind toward the unknown with relentless persistence. And after the moon landing, the question was no longer whether humans could reach another world, but whether they understood what such a capability truly meant. Because traveling to the moon required us to confront how fragile we are, how dependent we remain on thin layers of protection, how narrow the conditions for life truly are, because when astronauts looked back at Earth, they did not see borders or divisions. They saw a small, luminous sphere suspended in darkness, protected by a delicate atmosphere thinner than many clouds. And this perspective revealed something science had long suggested, but humanity had rarely felt emotionally: that Earth is not the center of the universe, nor is it guaranteed permanence. It is simply one suit. able location among many hostile ones. And this realization transforms the moon landing from a technical achievement into a philosophical one, because it forces us to reconsider what survival means in a universe that is vast, cold, and indifferent. And this is where the idea of impossibility reappears. Because sustaining human life beyond Earth is not simply a matter of repeating a journey. It is a matter of mastering environments that actively resist our existence, environments where radiation damages cells silently, where temperature swings are extreme, where resources are scarce and must be recycled with near-perfect efficiency. And the moon revealed this truth clearly, because it is close enough to reach yet hostile enough to teach humility, because there is no water freely available, no breathable air, no protective magnetosphere. And this means that the moon is not a second home, but a classroom, a place where physics teaches without compromise. And what it teaches is that technology alone is insufficient without understanding systems deeply, because a spacecraft is not a vehicle in the traditional sense. It is a miniature ecosystem, a carefully balanced network of life support, energy flow, thermal regulation, and structural integrity. And a failure in one component cascades rapidly into others, and this interconnected fragility mirrors life itself, because biological systems operate under similar constraints. And this parallel is not coincidental, because both life and machines must obey the same fundamental laws, laws that do not negotiate. And this is why extending human presence beyond Earth remains difficult, because it requires us to build systems that behave more like living organisms than tools, systems that adapt, self-correct, and endure uncertainty. And the moon landing showed that we could briefly sustain such systems, but it also showed how much effort was required to do so for only a few days. And when people ask why humans have not returned in the same way since, they often assume a lack of will or imagination. But the reality is more subtle, because science advances not by repetition, but by refinement. And after the moon landing, humanity learned that going further requires deeper understanding rather than louder ambition, because rockets alone cannot solve the challenges of long-duration space travel, because propulsion addresses distance, not survival. And survival depends on mastering radiation shielding, closed-loop life support, psychological resilience, and the ability to repair systems far from Earth. And these challenges are not dramatic. They do not announce themselves with explosions. They emerge quietly through accumulation of small stresses over time. And this is why the future of human exploration lies not in grand gestures, but in patient research, because the universe rewards precision, not bravado. And when we consider the moon again in this context, it becomes clear that it is a testing ground for understanding how humanity might one day move beyond a single planet without carrying Earth's entire biosphere with it. And this raises another uncomfortable question, because if humans are to survive long term, we must learn to exist in environments that do not resemble our evolutionary past. And this requires not only engineering, but adaptation, both physical and psychological, because the human mind evolved under skies that change, under gravity that pulls consistently, under cycles of day and night shaped by Earth's rotation. And removing these conditions alters perception, cognition, and emotion in subtle ways. And the moon landing revealed this too, because astronauts reported not only technical challenges, but shifts in awareness, a heightened sense of isolation, a deep awareness of dependence, fragile systems, and a sense of separation from everything familiar. And these experiences matter, because survival is not only biological but psychological, and any future beyond Earth must account for this, because intelligence alone does not guarantee endurance. It must be paired with wisdom, and wisdom arises from understanding limits rather than denying them. And the moon landing stands as evidence that humans can reach beyond their origins. But it also stands as a warning that such journeys demand respect for complexity, because the universe is not impressed by intention. It responds only to action aligned with reality, and this is why discussions about impossibility often miss the point, because impossibility is not a fixed category. It is a boundary defined by current knowledge, and boundaries exist not to discourage but to guide, because when we encounter a boundary we are being shown where understanding must deepen. And the moon was such a boundary because it forced humanity to confront vacuum, radiation, orbital mechanics, and the delicate balance required to preserve life. And these lessons extend beyond space exploration, because they mirror challenges on Earth, where systems are interconnected, resources are finite, and small changes can have large consequences. And if the moon landing taught us anything enduring, it is that survival depends on foresight, cooperation, and respect for natural law, because no individual nation or person could have achieved it alone. It required collective effort, shared knowledge, and trust in evidence over assumption. And this lesson remains vital as humanity faces challenges that are planetary in scale. Because just as physics does not care about borders in space, environmental systems do not respect borders on Earth. And understanding this may be the most important outcome of leaving our planet even briefly, because it reveals that intelligence capable of space travel must also be capable of stewardship. And if humanity fails to apply this lesson, then future journeys will be limited not by physics but by choice. And so, the moon landing remains a paradoxical achievement, both a demonstration of what is possible and a reminder of how narrow that possibility remains, because every step beyond Earth requires us to carry knowledge, discipline, and humility with us. And if we forget this, then even the simplest journey becomes impossible, not because the universe forbids it, but because we have misunderstood our place within it.